Hello everyone. In this video we are going to be solving trigonometric equations. In order to understand the examples I'm going to be treating in this video, you will need to have the knowledge of quadrats. To see the video on quadrats, just click on the link at the top right hand corner of your screen. Now, we know that there are 4 quadrats and the quadrat moves in a counterclockwise direction. So this is the first quadrat. And we've got the acronym all students take coffee, which of course is all, sine, tan, and cosine. So this is the second quadrat, the third, and the fourth. So this acronym tells us that in the first quadrat, all the 3 trig functions are positive, sine, cosine, and tan. In the second one, only sine is positive. In the third one, only tan is positive. And in the fourth, only the cosine is positive. And of course, in the first quadrat, the angles range between 0 and 90 degrees. In the second one, it's between 90 and 180 degrees. In the third one, it's between 180 and 270. And in the fourth one, it's between 270 and 360 degrees. All of this knowledge will come in handy in solving problems on trigonometric equations. One last thing, we also know that all of the angles in the second, third, and fourth can be expressed as an angle in the first quadrat. For example, in the second quadrat, the value of its angle in the first is related by this formula. Theta 2 is equal to 180 minus theta 1. Similarly, in the third quadrat, it's theta 3 equals 180 plus theta 1. And in the fourth quadrat, it's theta 4 equals 360 minus theta 1. I dealt with all of this extensively in the video I asked you to see the other time. Now let's solve a couple of problems. Here is the first one. If sine x minus 1/2 equals 0, find the two values of x within the interval 0 less than or equal to x less or equal to 360 degrees. So this is one full turn because the values of x range between 0 and 360 degrees. Now, to solve this problem, the solution, we would focus on this equation. Sine x minus 1/2 is equal to 0. Of course, this is the angle we are asked to find. So we would take the negative 1/2 to the other side. So this gives sine x equals 1/2. Now both this value on the right and the sign are very, very crucial. The sign actually tells us the position of the angle. So it tells us which quadrats the angle x lies, and the value here, 1/2, tells us the value itself of its sign. So how does this information play out? Now we've got the sign of an angle being positive. So we can see here that sign can only be positive in the first and the second quadrat. So that tells us that this angle here, this angle x, must either be in the first or the second quadrat. Good. So the next is going to be to move to the number. So we've got the sign of the angle being half. So we can just solve this. We know that if the sign of an angle is 1/2, then the angle is just going to be the inverse sine of 1/2. Of course, x is in degrees. So the inverse sine of 1/2 is 30 degrees. And we can tell here that 30 degrees is an angle that's between 0 and 90 degrees. So this is the first solution of the equation. So this is the value of the angle in the first quadrat. But the question is asking us to obtain two values. So since we know from the sign that there are two values here, one in the first quadrat and the other in the second quadrant. We already figured out what the angle is in the first quadrant. We are just going to use this relation, theta 2 equals 180 minus theta 1, to obtain the value of the angle in the second quadrant. Thus, in the second quadrant, theta 2 is equal to 180 minus theta 1. And already we figured out what the first angle is, what the angle in the first quadrant is, that's 30 degrees. So this is just going to be 180 minus 30, and this is equal to 150 degrees. So this is x, the second angle. Thus, we can see that the solution of this equation, sine x minus 1/2 equal to 0. So we've got x equals 30 degrees and 150 degrees. And we can check this against the equations. For example, we have that the equation is sine x minus 1/2 equal to 0. If x is 30 degrees, we would see that this is going to be sine 30 minus 1/2. Sine 30 is 1/2, so this is 1/2 minus 1/2. So we can see that we got a value of 0 that is equal to the right hand side. Also, if x is 150 degrees, this is also going to be sine 150 minus 1/2. Sine 150 is positive sine 30, which is 1/2. So this is 1/2 minus 1/2, and this also gives 0. Let's take the second example. Find two solutions between 0 less than or equal to theta less than or equal to 360 degrees, satisfying cos 2 theta equals -1 over root 2. The solution, the first is going to be the sign here, this negative sign, that tells us the position of the angle. So the negative sign tells us here that this angle would lie either in the second or the third quadrant, because we've got the cosine of an angle being negative, and the cosine is only negative in the second and the third. In the first quadrant, the cosine is positive. In the fourth, the cosine is also positive. So definitely 2 theta, the angle here, would lie in the second or the third quadrant. Now we've got cos 2 theta equals -1 over the square root of 2. To make our work easy, I'm going to let alpha be equal to 2 theta. It's going to be much more easier for us to solve this if the coefficient of the angle is 1. So if alpha equals 2 theta, that transforms this equation to cos alpha equals -1 over the square root of 2. And like I said, the negative sign here just tells us the position of the angle in the quadrant. That's all we need it for. Thus, I can just remove it and solve straight away. So I'm going to have cos alpha equals 1 over root 2. Now, if cos alpha is 1 over root 2, taking the inverse cosine, alpha is going to be the inverse cos of 1 over root 2, and this is equal to 45 degrees. Now, this is the value of alpha in the first quadrant, but we know it's impossible for alpha to be in the first quadrant. It's impossible because the cosine of an angle can only be negative in the second or the third quadrant. But since we know that every angle beyond the first quadrant can be represented as another angle in the first, so having obtained the value of alpha in the first quadrant, I can rely on the fact that in the second quadrant, an angle is always equal to 180 minus theta 1. So here I would have that alpha 2 equals 180 minus alpha 1. So this is going to allow me to obtain the equivalent angle of 45 degrees in the second quadrant. So since alpha 1 is 45 degrees, so this is 180 minus 45 degrees, and this is 135 degrees. So what this tells us is that 135 degrees in the second quadrant is equivalent to 45 degrees in the first. So the next thing is going to be to recall that alpha equals 2 theta. So we have alpha equals 2 theta. Substituting the value of alpha, so we're going to have 135 degrees equals 2 theta. Dividing both sides by 2, theta is going to be 135 over 2. Thus, theta equals 67.5 degrees. This is the first value of theta. Also, in the third quadrant, we know that the relationship between an angle in the third and the first one is theta 3 equals 180 plus theta 1. Thus, alpha 3 is going to be equal to 180 plus alpha 1. Since alpha 1 is 45 degrees, this is 180 plus 45 degrees. And this is equal to 225 degrees. Of course, this is the value of theta of 2 theta. But what we're asked to obtain is the value of theta. So if we divide both sides by 2, we would obtain theta as 225 over 2, and this is 112.5 degrees. So in conclusion, the solution of this equation, cos 2 theta equals negative 1 over root 2, is theta equals 67.5 degrees and 112.5 degrees. If you find this video useful, kindly like, share, drop a comment, and do not forget to subscribe. Thank you for watching. See you in the next video.